Alrighty, we're going to start the Unit 7 Section 2 notes. And in this section, we're going to build on what we talked about in Section 1 with exponents, but in this section, we're going to be talking about negative and zero exponents. So the first bit of notes we've talked about before, way back in Unit 2, but for any non-zero number, and we'll use a in this case, so for any number that has an exponent of 0, that always equals 1. So a to the 0 power equals 1, 15 to the 0 power equals 1, 7 to the 0 power equals 1. Any number raised to the 0 power always equals 1. The second part of the notes is when you have a negative exponent. So a raised to a negative power of n, that will always equal 1 over a raised to the power of n, just like I've written here. So let's go ahead and do a few examples. So 7 raised to the power of negative 5, that equals 1 over 7 raised to the 5th power. Number 2, we have 137 raised to the 0 power, and we know that any number raised to the 0 power simply equals 1. Number 3, we have 14g raised to the negative 8 power. So 14 is going to stay in our numerator, but our denominator will simply equal g raised to the 8th power. With number 4, b to the 3rd power, or b cubed, stays in our numerator, and a raised to the 7th power is in our denominator. So this section, we're going to simply write the expression without using a fraction bar, so with a negative exponent. Number 1 could be written several ways, but one way would be 4 to the negative 2 power, which would equal 1 over 4 squared, which would equal 1 over 16. Number 2 would simply be 5 times h to the negative 4th power. Number 3 would be 8d cubed e raised to the negative 7th power. All right, so now we're going to talk about using the power properties, which is what we talked about last time, or in the last section, but now we're going to use negative exponents. So in our first example, we have the same base of 9. So we're going to have 9, and we're going to add our exponents together. Negative 5 plus negative 6 is negative 11. We want to get rid of that negative exponent, so this equals 1 over 9 raised to the 11th power. Same thing here. We're going to have v raised to the negative 4th power, and that equals 1 over v raised to the 4th power. Number 3, we're simply going to multiply our two numbers first. So 3 times 8 is 24. Our base is the same. So s, 0 plus negative 5 still equals negative 5. And we rewrite that as 24 over s raised to the 5th power. If we look at number 4, now we're going to use our division property. So we have 5 as our same base, and we're going to subtract 12 from 6. So we'll have 5 raised to the negative 6th power, which equals 1 over 5 raised to the 6th power. Here, I'm going to divide 21 by 7 first to get 3. Then I'm going to subtract my h's. Negative 8 minus 2 is h to the negative 10, which simply equals 3 over h raised to the power of 10. Number 6, I'm going to simplify 20 over 16. I'm going to divide them both by 4. So that would leave me 5f to the negative 2 over 4f to the negative 14. If I rewrite this, I would have 5 over 4 f to the negative 2 minus negative 14, which simply would be negative 2 plus 14. So this equals 5 f to the 12th power, all of that over 4. right, continuing with this set of notes, we've got some review problems. Numbers 1 through 3 are simply using your integer operations and rules for integers. So negative 14 plus 98 is positive 84. 26 plus a negative 19 is positive 7. And negative 89 minus 23, remember we can also write this as negative 89 plus negative 23, and this simply equals negative 112. In the next section, this is also review. We're going to find the least common multiple of these two monomials. So the least common multiple of 6 and 12 is simply 12. Then we have x squared y cubed. Our least common multiple of 3y, 5x squared y squared would be 15 x squared y squared. I'm going to leave number 3 for you to try. Going down, we're doing the greatest common factor. So we're simply going to find our greatest common factor of 44 and 24, which is 4. Then our greatest common factor of the x's is x squared. So 4x squared is the greatest common factor. 21xy and 25x squared. We have 21xy over 25x times x. The only thing that's in common here is our x, so x would be the greatest common factor. Last but not least, 42x cubed y and 70xy squared. The greatest common factor there would be 14, and then we simply have x and y that they share. All right, that wraps it up for Unit 7, Section 2. Again, if you have any questions, please ask your teacher. Also, if you are finding the least common multiple or greatest common factor with monomials to be challenging, I would suggest that you go back and look at Unit 6.